Parachute seatbelt connected pins are removed and stowed before takeoff checks complete.
Test control copies concur. Your go from our perspective to line up. We will need to burn.
Copy.
Welcome back to another narrated flight test video with Boom Supersonic. This is our third video showcasing the 10th flight of XB-1.
Alright, throttles are coming up. Alright, showing myself in band.
Test control concur. You are go brake release.
Copy, go brake release.
The primary objective of today's mission is to expand Mach number all the way to 0.95, just 5% shy the speed of sound, and also demonstrate adequate handling qualities of the basic aircraft with its stability augmentation turned off while transonic.
Good retraction.
We did achieve our objectives on this flight, despite experiencing our first real in-flight emergency. I'll talk through all of that in this video.
Test control looking for 330, climb to 24,000 feet.
Copy, out of burner.
We're climbing up to 24,000 feet to set up for our first test point, a 0.85 flutter block at 350 knots equivalent airspeed.
Alright, I am on condition.
Test control your go HQ block.
Alright, everything feels fine.
Control F card 1 complete, and sub card 2 is the flutter block. You're clear to load profile 180-2.
Alright, 180-2 loaded. And I don't want to fall out of TM reception here, so I'm going to check it left 45 degrees. Oh, getting fast there. Okay, start 4 N65, duration 180.
Test control profile is confirmed. You are go for flutter block.
Copy.
Stand by.
Standing by.
One notable difference in today's mission is the support aircraft. Instead of our usual T-38, chase is being provided today by a Mirage F1 aircraft.
Test control, we had a drop out. You are go to perform profile 180-2.
Copy. Get another 30 degrees of turn here. Alright, rolling out. Arming the Fez. In 3, 2.
At the start of this test point, we were at the northeast corner of the restricted R2505. That's about 91 miles from Mojave, and just about as far away as we can get within our flight test area. We start to see a little bit of degraded radio comm and telemetry strength. However, it's still quite workable.
Profile's complete. Coming left.
Card 2 complete.
Concur, card 2's complete.
Test control, that was a good sweep. I'm on card 3. You are go. Would you like to do the HQ block?
Hey, firm. Rolling into a turn now. I'll keep this turn in for another 30 degrees. I'll come out of it with a roll step. And then out of the turn, chaser cleared pacer.
Chase. Control copies, you'll come out of it with a roll step. Just be advised your radio signal is pretty weak. We can still make you out, but just barely.
Copy. Alright, back to the right in 3, 2, 1, mark. Alright, feels nice and smooth, I like it.
Test control copies, watch your Mach number, your go pitch doublet, wind straight level.
Copy.
Chase set.
3, 2, 1, mark 369, 23, 930.
367-23860.
Copy. Alright, pitch doublet in 3, 2, 1. Mark. Controls quiet.
This is quiet, you go yaw doublet.
Alright, pedal doublet in 3, 2, 1. Mark. Controls quiet.
Trace is quiet, recover, and your go to climb to 30,000 feet.
Copy up to 30K. Starting an easy left. Alright, I'm gonna plug the blowers here.
Plug the blowers means engage the afterburners, which Geppetto does here on all 3 engines to speed up the climb. And take a look at that Mirage starting to drift back, trying unsuccessfully to keep up. We've actually demonstrated that XB-1 with its landing gear down will outclimb a T-38 with its landing gear up. And with the gear retracted, it climbs like a rocket ship.
Alright, I am on condition.
Control your go to load profile 180-2.
180-2 loaded, start 4 and 65, duration 180.
Test control your go for the Excel to 0.9.
Excelling to 0.9.
We have chosen 30,000 feet to expand the envelope to 0.9 Mach. This will be our first time at this altitude and Mach number, but the specific combination means that we will be at 325 knots equivalent dynamic pressure, which we have used for all of our Mach expansion points to date. We strategically separate Mach and dynamic pressure, only expanding one at any given time.
Alright, I'm on condition 0.9.
Control, how's it feel from a quick look?
Good to go.
Test control your go to perform profile 180-2.
Copy 180-2. Armed and running in 3, 2.
Caution.
Alright, profile's complete. Coming left.
Control.
Copy fuel state chase. I'm a 3-2, and we've got a INS pause accuracy.
Test control, we see that. Continue. Good sweep.
Copy.
We're on card 5, and your go for pacer check.
Copy. We'll turn this turn into a HQ block.
Control.
Okay, everything feels smooth.
Test control, that position accuracy has no effect on dampers.
Copy. Alright, keep the turn in a little bit longer here, and then I'll use a roll step to come out.
Control.
Okay, saw a momentary INS degrade. Lost the flight path marker momentarily, but it's back. Alright, rolling right in 3, 2, 1. Mark. Remarkably smooth and predictable. And chaser cleared pacer.
Chase step.
3, 2, 1. Mark 348, 29, 600.
351, 29, 540.
Test control, you're our go pitch doublet when set.
Copy, pitch doublet in 3, 2, 1. Mark. Controls quiet.
This is quiet, your go yaw doublet.
Okay, pedal doublet in 3, 2, 1. Mark. Controls quiet.
Trace is quiet. You are go to climb to 32,300 feet, maintain 0.9er.
Up to 32.3.
With all of that initial Mach 0.9 testing complete, we're climbing up another 2,300 feet to set up for the expansion to 0.95 Mach. Again, because of the choice in altitude, we will also be at 325 knots equivalent dynamic pressure. But before we get to expanding Mach, what you're about to see is the unaugmented handling quality evaluation at 0.9 Mach. We are transonic at this point, and thus the modeling of the aircraft behavior is the most uncertain that it is anywhere. I won't make any commentary for the next several minutes, so you can just observe what is going on.
Alright, I am on condition at 32.3.
Test control, I'm on card 6, your go, step 1, pitch damper off.
Alright, pitch damper's coming off in 3, 2, 1. Mark.
Test control, your go, HQ block.
Copy. Alright, here comes a little pitch doublet in 3, 2, 1. Mark. Control's quiet. Alright, not nearly as springy as I thought it was going to be. It seems pretty well damped.
Test control, concur, your go, step 3 and 4, pitch on, roll off.
Alright, pitch damper's coming back on. And roll damper coming off in 3, 2, 1. Mark.
Test control confirmed, your go, HQ block.
Copy HQ block. We're going to be starting a turn here to the left in just a second. Alright, we're going to do a 30-30 bank reversal. Back to the left in 3, 2, 1. Mark. Alright, pretty smooth and predictable. Let me keep this turn in for a little bit, and then I'll get you a pedal doublet, and then we'll be ready to move on.
Control.
Alright, here comes the pedal doublet in 3, 2, 1. Mark. Control's quiet. Okay, everything seems pretty well damped. Ready to continue.
Test control, your go, step 6, 7, and 8, roll on, yaw off, ARI off.
Copy, roll dampers on. Yaw dampers coming off in 3, 2, 1. Mark. And ARI in 3, 2, 1. Mark.
Configuration confirmed, your go, HQ block.
Copy. Alright, roll is quite a bit more sluggish. Alright, get a roll step here from 30 right to 30 left in 3, 2, 1. Mark. Yeah, a little bit of ratchetiness, but smooth, certainly acceptable for retreating to a known flight condition. And pedal doublet in 3, 2, 1. Mark. Control's quiet. Alright, looks pretty well damped, ready to continue.
Test control, and just be advised your radio is continuing to degrade, but your go, step 10 and 11, pitch and roll off.
Copy, pitch off and roll off.
Config confirmed, your go, HQ block.
Copy, HQ block. Alright, a little pitch doublet in 3, 2, 1. Mark. Alright, looks like 5 or 6 overshoots. Alright, setting up to the right and coming back to the left in 3, 2, 1. Mark. Pretty smooth and predictable. Generally pretty happy with the handling qualities. Damper's off. I'm going to keep this turn in for a little bit, and then I'll get you a pedal doublet and I'll be ready to continue.
Control copy.
Alright, rolling out. And ready for step 13.
Test control, did you want to do a yaw doublet?
Oh yeah, thanks. Yaw doublet in 3, 2, 1. Mark. Control's quiet. Alright, happy to continue.
Okay, test control, your go step 1-3, ARI on.
ARI's coming on in 3, 2, 1. Mark.
Config confirmed, your go HQ block.
Yeah, I don't really like it. It's pretty touchy and roll and not very predictable. That's all I want to do with that.
Test control, understood, your go step 1-5, everything back on.
Alright, everything's coming back on.
We learned a lot during this series, and were pleasantly surprised that everything felt as good as it did, even with all of the stability augmentation turned off. A real testament to the tremendous work of our aerodynamic and flight control teams. That last point where Geppetto says, "I didn't like it," was a configuration where we turned on the aileron rudder interconnect system without any other dampers being active. We have learned through flight tests that this system provides more benefit at slower airspeeds, but actually makes things worse at higher Mach numbers if the dampers are not on at the same time.
Test control config is confirmed. We have clearance for .905. I'm on card 7. Your go to load profile 180-2.
Alright, 180-2 is loaded. Start 4 and 65, duration 180, coming left.
The clearance we now have came from the flutter station. The whole time we were doing that handling qualities evaluation, the flutter team was furiously reducing the data that we collected during the last flutter block only minutes ago. The team has developed some truly impressive software tools that enable us to provide these in-flight clearances and have the confidence that we will be safe at the next Mach number.
Control, do you intend to point south for this run?
Affirm.
Test control, if able, could you get breaker hotel 12, cam 2, pulled out for 3 seconds?
We pull that circuit breaker to turn off one of the forward-looking landing cameras. We're trying to troubleshoot some low GPS signal strength that we have been experiencing on a few flights, but this ended up not being a factor.
If this heading will work, I'm ready to excel.
Control, your go for the excel to 0.905.
Copy, out to 0.95. Center throttle's coming to afterburner. Alright, I'm on condition, ready.
Right, control, your go profile 180-2.
Copy, 180-2. Armed and running in 3, 2. Profile is complete. Chaser cleared pacer.
Chase set.
3, 2, 1. Mark 347, 32, 100.
348, 32, 160.
Test control, say again your altitude.
32, 100.
Test control, good sweep. I'm on card 8. You are go pitch doublet.
Copy, pitch doublet in 3, 2, 1. Mark. Control's quiet.
Trace is quiet. Your go step 3, yaw doublet.
Pedal doublet in 3, 2, 1. Mark. Control's quiet.
Trace is quiet. You go roll step.
Alright, we'll start to the right. And to the left in 3, 2, 1. Mark. Alright, pretty smooth. I'm going to keep this turn in. Alright, everything feels pretty good.
Test control, we have clearance for the .85, 370 key point.
Copy.
A few things happened pretty quickly there. We received clearance for a different flight test point that was a stretch goal for the mission. A 0.85 Mach flutter block at higher dynamic pressure that would have de-risked what we planned to do on our next flight a little bit. But we experienced an unexpected failure where DAS-4, one of our data acquisition units, faulted out.
Okay, I got a DAS-4 fail.
All altitudes 2515, thank you. Kestrel 11.
88.
It might have been hard to hear, but I said page 88 on the radio. I'm referencing our emergency procedures book. There are 132 pages in there worth of pre-thought-out procedures for just about any conceivable failure. This is actually the first time outside of our numerous training simulations where we have had to use one of them.
Test control with the EP up.
Ready.
Step 1, DAS 4 circuit breaker, Delta 9, pull, then reset.
Alright, Delta 9 is out. And reset.
And there's a note here that it will take approximately 2 minutes to reset.
Copy. Looks like the only thing I've lost is RPM, afterburner, nozzle position, and pitch and yaw trim indications.
Yep, also oil pressure is lost. Ram air control valve command voltage. Generator coil temperature monitoring.
Copy.
Monitoring.
Alright, I don't want to run the profile with this, so I'm going to keep descending down. We'll get set up to land.
Test control concur with that. Expect it might come back in 2 minutes. If not, the remaining step of the EP is to land as soon as practicable. EP complete.
Copy.
If Geppetto seems cool as a cucumber, even though there's an active emergency going on, it's because, other than the fact that he's a badass, we have trained for this type of thing many times in the simulator. And if we had to experience one of the failures we dreamed up, a DAS 4 failure is not that bad of an option. The avionics subsystem has 6 data acquisition nodes throughout XB-1. DAS 4 collects many, but not all, of the engine instruments, and provides data to the control room as well as the primary display in the cockpit. Other DASs on the aircraft contribute to other critical functionality, like damper control, just as an example. The recovery actions for this emergency procedure are relatively simple, and only involve rebooting the DAS in question with a circuit breaker cycle. But it's important in these situations to keep a level head, properly diagnose what has happened, and take the correct actions. Pulling the wrong circuit breaker, or misdiagnosing the failure as something worse, like an engine malfunction that the instrumentation may suggest, could lead to a bad outcome.
Test control, that looks like a good reboot for and airline reports, no other anomalies.
The emergency has seemingly resolved with a successful reboot of the DAS node. We'll launch an investigation into the reason for the failure once we get back on the ground.
Okay, we're cleared to switch tower.
Copy up tower with you, and control copy all. Looks like we got a good jet.
Test control concur, acknowledged.
Kestrel standby gear. 3, 2, 1. Mark.
Check out this shot of the landing gear coming down. As a landing gear designer, it makes my heart melt a little bit.
Alright, 3 down and lock, dampers on, fuel systems auto, anti-skids auto.
Kestrel 1-1 flight Mojave Tower, runway 30, wind calm, clear to land.
Kestrel 1-1, we've got 6 down and locked. Kestrel 1-1 will be a full stop. Kestrel 1-2 will turn downwind.
Test control, everything's green in the control room, you're go landing.
Roger, if you can on the go enter a left
Caution.
downwind for runway
Caution.
30.
That caution is alerting the pilot that he has a low fuel state, but it's expected and not a problem because we're moments away from landing.
Alright, landing checks complete, and copy landing clearance.
Dev, battles contact. You're a little high, you're on center line, winds are light and variable.
Test 1.8, full stop.
Caution. Caution.
Full stop. You're on center line. You're on line. You're on center line. You're on glide. You're on center line. You're on glide slope. 50 feet. Center line.
Steady 0 Mojave Tower, line up and wait, runway
20. 10.
And again, Geppetto makes it seem easy. Thanks for watching, and keep following the channel. Our next flight is planned to be supersonic, and we will be broadcasting the attempt live on this and other platforms.